So our first unit is an introduction to physics and looking at measurement. Physics is a science that deals with matter and energy and their interactions. And so that's the basic definition. We're dealing with matter and how they interact with each other and considering the energy involved. Science in general is considered to be the search for order in our observations of the world around us. So physics falls underneath that, and if you think of the other disciplines, you can consider that as well, and trying to find order and patterns in what we see. And so what I like to ask in class is, how would you describe the search for order in chemistry compared to biology? So if you think of chemistry, we're looking at the basic building blocks of the universe and trying to find order. Are these different elements acting the same? Are there different patterns? How do those combine together, in making molecules? And in biology, you're finding patterns in life and looking at, the patterns in animal cells versus plant cells and things like that. So, even if you're not considering a science or math related field for your future, hopefully this class will give you a good background on how the world works and really seeing that, how amazing the universe is and how ordered and beautiful and magnificent it really is. And so we'll explore all the way down to the really, really small to the really, really large and see how the universe functions. So we'll look at things as small as an electron. An electron is an example of a subnuclear particle, and it's very, very, very tiny. And when we look at the orders of magnitude in terms of how small something is, 10 to the negative 15th meter is extremely small, and it's almost hard for us to even imagine. And the amount of mass that we're talking about is very, very tiny as well. So 10 to the negative 30th kilograms. So that's 29 zeros, or point, a decimal, and then 29 zeros and a 1. So it's very, very small. Time across the nucleus, if we shine light across the nucleus, it takes a very, very short amount of time. And that's an objective way to talk about how long it is. How large, the distance of the visible universe, what we can see, 10 to the 25th meters. Again, just enormous size. It's hard for us to fathom that size. The mass of the universe, the approximate mass of the universe, 10 to the 50th kilograms in orders of magnitude. And the time of the age of the universe, and so based on the Big Bang model, 10 to the 18th seconds. And what we'd like to do with the kind of perspective, looking at the universe, the atlas of the universe.com is a great way to visualize the universe, the size and scope of the universe. So one way to measure an astronomical length, and really a helpful way, is to look at light years. Light year is the distance light travels in a full year. And so it's this many meters, so we can look at that and see that's a very, very large number, but that's only one light year. And so to give you a perspective in terms of the distance from the Earth to the Sun is this many light years. It takes about, it's only a very, very small fraction of a year. It's about 8 minutes for light to go from the Sun to the Earth. And, a good discussion that we can have is, how do we actually know the size and scale of the universe? And that's something good to ponder. How do we actually know this? So if we look at within 12.5 light years from the Earth, we're dealing with only 33 stars. And so if you look on the screen here, and let me get a color that you can see, the galactic center is pointing this way, and so here's the Sun. And so what you can do here is, for instance, let's look at the star Ross right here. What you would do is you come out on this radial from 0 degrees, and then you go down. And this is trying to show three-dimensionally on a two-dimensional screen here, and that's where Ross is. So it's, if you look at the scale here, 10 light years, you can visualize how far that is away from the Sun here. Here's another one up here, so you would come along this radial here and then go up to it. Actually, sorry, this radial here and then go up to it up here. And that gives you some perspective. 12.5 light years from Earth, we would have 33 stars. As we zoom out within 250 light years, we get 260,000 stars, which is, which they're trying to depict here with some of the ones that are listed here are brighter than the sun, and you can actually see with the naked eye the ones that are listed. And if you notice, there's a lot of Greek letters. We can see those with our naked eye, so these have been seen for a long time. You think about, the Greeks and the learning, if they've named these, and these have been named for a long time. Within 5,000 light years, we're in the corner of the Milky Way galaxy, and we're located in the Orion Arm. And, the spiral, the most notable group of stars is the constellation of Orion. So that's where we get the spiral arm. We get its name from there. And, we have these stars that are listed here are bright and supergiant stars, thousands of times more luminous than the sun, and we can actually see these. And so these are listed here, and you can actually start to see these rings of the Milky Way. So we go to 50,000 light years, we can see the full extent of the Milky Way galaxy, and we're looking at 200 billion stars, which is, again, these numbers are just staggering. They're hard for us to picture. The sun is buried deep within the Orion Arm, about 26,000 years from the center. And towards the center of the galaxy, they're packed much closer together. And but we're here in the Orion Arm, and just where we need to be. For any closer, any further away, life would be impossible. 5 million light years. Milky Way is one of the 3 large galaxies belonging to the group of galaxies called the local group. And so there are several dwarf galaxies that we have. And it's interesting, where we are here, we're decently far away from other, like the Andromeda galaxy. And that's really helpful, because if these galaxies were closer, we would have a lot of light pollution. We wouldn't be able to see out into space like we can. We're actually at a very good location to be able to see the universe. And so our galaxy is one of the thousands that lie within 100 million light years. And this map here shows the nearby cluster, the Virgo supercluster. So these are clusters of galaxies. Now these white dots are actually clusters of galaxies, and or galaxies themselves. And the Virgo cluster, all these dots represent the cluster of them. And so here we are in the local group, and then we're pretty far away from the, well, everything's relative in astronomy, but far away from the Virgo cluster. 100 million light years, we can see there. So 10 million, is the scale here. So Virgo cluster, is closer than, a little bit closer than 100 million light years. As we keep zooming out, we get to 1 billion light years. Again, it's just kind of staggering to think about this. The galaxies and clusters, galaxies are not uniformly distributed. And there's sheets and walls that you can see here, and this is the 77% of the visible universe, what we can see. So we're here, in the middle. Virgo is listed here, and you can see all these different superclusters all scattered around. And as we keep zooming out, we get to the visible universe, 14 billion light years. And the universe has expanded from the beginning, and it's continuing to expand. So this is what we can see. The actual universe is much larger, than we can see right now, and we'll be talking about that more as we continue.